everyone. This is the second part of Pinacol rearrangement where I will focus on semi-Pinacol rearrangement. So it will be easier for if you watch the previous video, which is the basic Pinacol rearrangement, the link for which you can get in the description box, or you can click on the link top right corner right now appearing on the screen. So what is semi-Pinacol rearrangement and how it is different from Pinacol rearrangement? So in Pinacol rearrangement, as you can see, we have vicinal diol at 1 and 2 position, we have OH group. But when it is semi-Pinacol, one of the OH, it is now written as LG. So in this rearrangement, one OH group along with other good living group, it may be tosylate, mesylate, X or nitrogen, must be present in the substrate. That is the difference. Fine. So tosylate OTS, mesylate OMS, and this is halogen and N2 plus, but when it will be removed, it will be neutral nitrogen molecule. Fine. So here the OH group provides the electron to push the migrating group. So that factor is common for in both cases. So it is just pushing one of the migrating group like this. So that you have already seen in case of normal Pinacol rearrangement, right? But the pull comes from the departure of leaving group. So this departure of leaving group, that depends different types of leaving group, that is in case of semi-Pinacol. But when it is normal Pinacol, this OH is converted to OH2 in presence of H plus, and now it is removed. Fine. So that is the difference between these two. In both cases there is push and pull, but the pull comes from the departure of leaving group in case of semi-Pinacol, whereas in case of normal Pinacol it is water. Okay. And most important point, semi-Pinacol rearrangements are more regioselective. Now the question of regioselectivity arises when it is not symmetrical. But in this molecule you cannot understand it because both the OH, same environment, chemical environment, they are present. So any OH you can protonate. But in the next slide you will see that when the question of regioselectivity arises, semi-Pinacol rearrangement, that is more regioselective than the normal Pinacol rearrangement. So first we will see when tosylate is as leaving group. So after tosylate, next example will be for halogen and this for N2 plus. So when tosylate as a leaving group, and if we have taken this type of substrate, suppose this is 1 position, this is 2 position, this is 1, 2 vicinal diol. So when it is normal Pinacol rearrangement, you expect the positive charge generated at carbon number 1 because this is 3 degree. Obviously it is more stable than the carbocation at 2 position. So that is why positive charge will be generated here, and finally there will be these electrons will be pushed, and one of these hydrogen that is present here, it will migrate to 1 position and ultimately you will get aldehyde. But when it is semi-Pinacol rearrangement, now in presence of tosyl chloride and pyridine, this OH will be converted to OTS because it is easier that this OH is converted to OTS. Remember, a less hindered OH such as primary, that will be converted to OTS. So this is selective. It will not be happening for the other OH. So selectively we are converting this OH, and now this OTS will be the leaving group, and as if the reaction will be now opposite. So in case of the first case, you are seeing the positive charge is generated at 1 position and now it is generated at the other position. Numbering is different, but just ignore that fact. It is generated at the right hand side, right? And if you have do not have any prior idea about this OTS, so just see, suppose this is any alcohol ROH, R is any group, and this is TSCl, right? This molecule is TSCl. In presence of pyridine we are doing this reaction. So this H and Cl is removed, and oxygen sulfur, this bond now you are getting. So acid is removed in presence of pyridine, that is pyridine is removing this, helping to remove this HCl. So ultimately we are getting ROTS, this type of conversion of OH to OTS. So now at this position of OTS, next what is the reaction? In presence of very weak base, because we are not using any acidic condition, in presence of very weak basic condition, now this OTS will be removed, and as you can see here at 2 position there will be C double bond O, and this 2,3 bond is now broken and this bond is shifting here. So from 6-member ring now we are getting 7-member ring. So it may depend, that is, suppose you want to make this molecule, then you follow normal Pinacol rearrangement. But if we are wanting this type of compound, so it is not just sometimes more regioselective, because in this case maybe that at one position you are getting the carbocation and that will give you major product, and in other case also there is regioselectivity, but it is not just more regioselectivity, sometimes the position of this regioselectivity it is completely reversed, that you can see in this example. Okay, one more example, when tosylate as a living group, here we have this 1-2 position, again 1 position 2 position, there are 2 OH group. Now this is 2 degree alcohol, as you can see the left hand side and the right hand side there is 3 degree alcohol. It is not just 3 degree, there is also some CC double bond. So if the positive charge is generated at this position, it will be stabilized because of it is 3 degree as well as it is allylic. So when you are doing normal pinocol, positive charge will be generated here, but when you are doing tosylation by TSCL and pyridine, then secondary alcohol, that is this alcohol, secondary alcohol in presence of tertiary alcohol selectively will be converted to OTS. And now finally if you follow this blue arrow, there will be this lone pair that will be pushed, and these 2-7 bond that will be migrating. So here 2-7 bond will be broken and 1-7 bond will be formed. So from 5-membered ring we will be getting a 7-membered ring. And see the same weak basic condition we have seen, we cannot take any acidic condition, we also have this protection here. So these examples you can get in Clayden, and page number everything I will give in the description box, you can check there. Next, halogen as a living group. Now what is happening? Now this molecule looks scary, but actually see, if you simply consider this portion as if it is a group R, then it is not so very complex molecule. Now in presence of AgNO3, which is source of silver plus, this iodine will be removed as a form of silver iodide, and this carbon iodine bond is broken, positive charge will be generated at this position. Fine. So this is our living group, positive charge is generated. We have done some numbering so that we can understand how the bonds are broken and new bonds are formed. So this is pushing these electrons, and this is helping to this CC bond migration. So here 6-2 bond that will be broken and it will be coming at this position. That means 1-6 position you will be getting a new bond. So see, now 2-6 bond is broken and at 1-6 position there is a new bond. And as I have said, simply consider this as R group. So nothing is happening in this part. Our focus should be on at these positions. Okay. Next is N2 plus as a living group. Now this reaction is also known by this name reaction, Tiffeneau Demjanov rearrangements. Now look at this molecule. Here we have taken 1 position, 2 position, but instead of 1,2 diol, now at 2 position we have a good living group which is N2 plus. Now this molecule, that is straight you cannot get, obviously you have to make this compound, but before that just focus on this part because that is our main topic of discussion. What is happening here? This is pushing these electrons, and one of the pH, it is pushing this migrating group to shift to this position, and nitrogen is living. Now nitrogen is a very good living group because this is a very stable molecule because of its triple bond. So very good living group, and easily we can get this product. But how to make this compound? Simple. In presence of, that is simply diazotization, in presence of NaNO2 dilute HCl, there will be formation of nitrous acid. There will be formation of nitrous acid, and this will be formed, and you can get N2 plus, right? So in this way we can make this diazotization starting from 2 amino alcohol. 2 amino alcohol, why? Because this is with respect to H, this is position 2. So semi-pinacol rearrangements of this type of diazonium salts that are derived from 2 amino alcohols, sometimes called this name reaction, Tiffeneau Demjanov rearrangements. Now this name reaction, this is a very good reaction if you want to increase the ring size, ring expansion of cyclic ketones. Then we can apply this reaction. So one example we will see, ring expansion, where this is our 1 position, this is 2 position. Now at 2 position in presence of HNO2, which actually we make by NaNO2 dilute HCl mixture at a very low temperature. So NH2 is now converted to N2 plus, and rest of the things you know. So 1,6 bond that will be now shifting here. So 1,7 bond, 1,6 bond is broken, and there is a new bond generated, which is this 6-7 bond. So ring size is increased from 6, now we are getting 7. Okay. One more example, but now we are not doing any diazotization. See what we are doing. We have taken a cyclic ketone, and in presence of diazomethane CH2N2, which you can write in this way, there is a negative charge. Overall this is neutral, but negative charge over CH2 and positive charge over nitrogen. If this is attacking here, there will be negative charge over oxygen. So this will also behave just like the previous reaction. Only difference is that we have we are using CH2N2. That is the difference. Now see the numbering. If you follow the numbering, this will be coming again, and 1,6 bond will be broken, 6,7 bond will be formed, and this is our nitrogen leaving group. So now the CH2, as if it is inserted between 1 and 6. So this is our newly generated bond, right? So this reaction you can also do the same thing in this way. So when diazomethane adds to a ketone, the product undergoes ring expansion by rearrangement of the same type of intermediate. Only difference here, you have O minus. Otherwise it is same. Now the problem may arise in this reaction is that here both starting material product are ketone. So this is 6-membered ketone and this is 7-membered ketone, right? So the reaction can occur cleanly only if the starting material is more reactive than the product. Suppose the product is, if it is more reacting, in presence of CH2, it can again come back to the starting material. So here cyclohexanone we have taken, and the final product, it is 7-member, and as we know, a 6-member ring cyclohexanone, it is more stable, more reactive than the other one. So that is why this reaction can occur cleanly. Fine. So this is the reason we can do this reaction in this way. The next reaction, here also we will see these Tiffeneau Demjanov rearrangements, but we have taken different diastereomers of 2-amino alcohol. Okay, so this is also from Clayden. You can get the page number in the description box. So see here, total 4 2-amino alcohols are present, right? So suppose this is number 1, this is number 2, this is number 3, and this is number 4. So from 1 and 2, which is written in the same line, why it is written so? Because we are getting the same product. So this is equatorial, and here it is equatorial axial, or everything is mentioned here with E and A. So when you have these two diastereomers, you are getting ring contracted product like this, as if this part, that is the carbon containing OH, it is converted to CHO, and this position there is some connection. So 6-member ring converted to 5-member ring. If it is the next molecule 3, now we are getting again 6-member ring, but this position we have C double bond O, and NH2 group is not present. And the last one, this is very interesting compound we are getting here, and that is epoxide. Now just because of this different axial and equatorial position of NH2 group and OH group, we are getting different types of result. Okay, so one thing I forgot to mention here, we have to take NaNO2 and dilute HCl mixture, that is a diazotization condition under a very cold condition, that is 0 to 5 degrees centigrade. So reaction condition is same for all, but we are getting different products depending on which diastereomer you have started with. So what is happening here? Let's see in detail. So this is molecule 1 and this is molecule 2. So from molecule 1, obviously NH2 is converted to N2+. Now this bond and this bond, just do the same thing in the other molecule also, that is the molecule second one. So these two are anti-periplanar position. So what happens here? This is the bond which will be migrating, and this CN bond that will be broken. So here, as the N2, which is the leaving group, departs, electrons in the bond to the migrating group, that is in the CC, the sigma bond, bonding and anti-bonding. So the electrons in the bond to the migrating group have to flow in the CN sigma star orbital. So you have to consider sigma star for CN bond and the sigma for the CC bond. So sigma as if, and this is sigma star. So these two, bonding and anti-bonding overlap, it occurs best when they are in anti-periplanar position, and that is the reason this is coming here, and this part there is, though here it is equatorial, it is axial, but it doesn't matter anything. So ultimately this is coming here. So this is the connection point, and this part is converted to CH2. So from both you are getting this same product. the next molecule, which is number 3. So in this case also, see, the NH2 group is first converted to N2 plus, and now at anti position we have this carbon hydrogen. So that is why this hydrogen will be migrating now. So this hydrogen is migrated as if it is hydride, and ultimately nitrogen is removed, and it is still 6 membered because no CC bond migration, only hydrogen. Now this is at a suitable position, that is anti position with respect to the CN bond. And what about the last molecule, that is number 4? Here COH bond, that is at anti position, right? So this is at anti position, but OH group cannot remove. So what you can do maximum? So epoxide will be formed. So this is as if it will be formed in this way. So that is why it is above the plate. Okay. So that's all for this video, that is semi-pinacol rearrangement. In the next video I will be discussing pinacol rearrangement, that is rearrangement in epoxide in pinacol fashion. So that will be the topic of the next discussion. So thank you for your precious time.